Welcome to Google Cloud Study Jam Session 4. In the last week, we have learned about generative AI, GANs, and services offered by the cloud. So, now in this session, we'll be talking about compute engine, serverless computes, cloud storage data types, and hands on with the cloud console. So, let's go with the cloud compute. So, what exactly is cloud compute? GCE, it is known as short for the Cloud Google Compute Engine. It is a cloud computing service offered by Google Cloud Platform. These are especially made up of scalable and customizable virtual machines. These virtual machines allows us to run applications, host websites, process data, and much more within the Google Cloud. It is leveraged by many big and small enterprises to its platform for the advantages of it, such as cost, speed, vivid data, big data, machine learning algorithms. This Google Compute Engines, these are as and comes under infrastructure as a service. These allows us to execute workload on the servers of the Google. There are many different types of virtual machines. Today we'll be talking about four. Let's talk about first one, general purpose virtual machines. These are especially for the daily task and the small enterprises. You can use for your daily task and it is very compact based. And this pricing also very affordable. When we go into the computer optimized, this is the second one. These are especially made for the computing performances. And when we go into the memory optimization, when we have such as large data sets, when we need to when we have large information together, then we'll be going for the memory optimized virtual machines. Whereas when we come into the fourth one, accelerator optimized, we have a special GPU from the Google, which is called as A100 GPU. This is especially for more efficiency when these are specially made for communications. When we need data to be transferred in the very fast, then we are going to use this virtual machines. Now let's take a real life example. So let's say 1 year back you have taken a let's say you have started a small business. So you have gone for the physical service. So now in this past few months you had a lot of traffic, lot of users coming for you. So now you need more scale, more resources from the physical servers. So what you are going to do? If you need to change your servers, it is going to a little bit of time. So you need to stop your workload. So in this time, the compute engines enters. So here, these are especially virtual, based on virtual machines. You will be putting your applications or websites on the virtual machines and running them in the Google servers. It makes it more simpler. So you don't need to change your servers. Why we need compute engine, especially for the scalability. So as from my example, when you need more scalability, you need to change the physical servers. Whereas if our virtual machines and compute engine, we can just increase our scale from the Google servers itself. So why exactly we need compute engine? Let's go. So for general purposes and optimized virtual machines. So here we can be using for our daily tasks or small enterprises, or else we can go into the big projects and we need more computing speed and engines. Then we can go into here. Let's talk about let's say we need a new computer. Like we need to make a new computer. So you will be selecting your own RAM, your own resources, what type of performance you need from the computer itself. Or you can go for the Google predefined machine types. Actually, Google offers a many large scale machine types from very basic small to large resources. So when we talk about scaling, how does Google know? So now whenever we need more scaling, let's say my resources are full and I am having a lot of traffic. So now our Google itself gives a recommendation to increase or to decrease our resources based on our utilization. Let's take another example. Now let's say we need to let's say our physical servers itself in Bangalore, and we are changing our location to Mumbai. So now also we have to shut down our physical servers and then take it to the Mumbai and again open them and then start our work. Instead of that, we can just use our uh, compute engines to just change the servers itself. So This is basically for example for the live migration. Now let's talk about serverless compute. Until now we have seen how to upload our code into the virtual machines and then they are uploaded into the servers of the Google Cloud. Now what if we don't even have virtual machines and directly going into the serverless? So here you will be focusing directly on your code and then just uploading them into the serverless computes, and only this serverless computes will be taken care of the memory utilization, whatever the resources we need. The main important features of it is auto scaling. Like whenever you need more scaling or whenever you don't need any utilization at all, we can the serverless computes automatically reduces or increases the scaling amount of resources, and you don't need to care about the hardware or shifting, shutting down, and let's say uploading everything. And this actually increases the speed to the market. How? Like let's say you are having a new prototype, you just need to see how it goes into the market. So you just upload it and you will be seeing how it works, and you need any more debugging or you need any extra features needs to be added. Whereas in the physical servers, we have to add and taken care of the hardware itself. When we use serverless compute, everything will be taken care of the computation itself. So here we can, this is mostly used for the, let's say, we need more features in our prototypes. So here we can directly use the serverless compute. Now let's see what are the types, what are the products offered by Google. So these are the main three serverless compute products: App Engine, Cloud Run, and Cloud Functions. The main focus on this is to just execute our applications without any server. So well, let's see the differences. Whereas in the App Engine, you will be just uploading whole you will be uploading your whole code into the App Engine, and the Google Compute serverless compute will be taking care of the memory utilization, what are the APIs, what needs to be taken care. Whereas when you go into the Cloud Run, you will be saving some of resources in one container and some of the resources, some of the codes in one container. So it is mainly used in incoming, taking request from the incoming users and giving responses to it. Whereas in the Cloud Functions, it is mainly focused on the triggers. So whenever you, let's say for the events, whenever you are doing this event, some other thing needs to be happening. For that, we will be using Cloud Functions. So let's see how Cloud Functions are used. Let's say we one user did one of the event. Let's say we need some information one of a server. So he clicked on one of our application. So from that we will be getting a trigger to our cloud. So from there we will be giving whatever the information we have, or if we need outside information from other APIs or from other servers, we'll be taking care of that and we'll bringing the information from there to here, and then we will be giving it back to the users. Now, Yagna will be talking about the storage types. So as you can see in this picture, we have many different storage types. So we'll basically see on what cloud storage is all about. So cloud storage is a service that is provided by the cloud computing providers to storage, manage your data remotely. And it is highly scalable. That means it allows the users to either increase their data or decrease or like storage capacity whenever they require. And it is cost effective as users only pay for the store amount of data they're storing. And the common use cases for the cloud storage are mainly content storage and delivery, storage for data analytics and general compute, backup and archival storage. So content storage and delivery is refers to storing various types of digital content such as media files like images, videos, music, and web assets like HTML files or CSS files, JavaScript, etc. So these cloud storage enables efficient distribution of this content to users around the world. Let's say we give an example. So we have streaming services like Netflix. So the content that is stored in the Netflix that we see is all stored in cloud. And when the user wants clicks on a movie, per se, then they can access that particular content from anywhere using their devices. So whenever a user selects a movie to watch, the video is delivered in the device in real time. So providing a seamless viewing experience.
So cloud handles the storage management and delivery of vast amounts of video content to millions of users worldwide. So that is about content storage and delivery. Next, coming to storage for data analytics and general compute. So cloud storage is widely used for data analytics, for general computing tasks, and like for accessing large data sets, storing them. And the benefits are basically that data can be seamlessly integrated with various analytics like machine learning tools available on the cloud ecosystem. One example can be an e-commerce website like Amazon. So the platform collects and stores vast amounts of structured and unstructured data, which we'll be doing it in the next slide, including like customer orders, product prices, enabling the data analytics to understand the customer behavior and what products are being sold like at a high range. The next is backup and archival storage. So backup and archival storage in cloud involves securely storing copies of very sensitive or critical information, which help in disaster recovery and long-term retention. So these data that is there in the cloud replicates data across multiple data centers, ensuring high availability of the backup data. And coming to an example, so example can be healthcare data archiving. So in the healthcare sector, electronic health records need to be securely stored and accessible. So which contain the patient's name or age or the type of healthcare they're taking required, or diagnostic images, their results, etc. So the data is archived and can be retrieved whenever needed based on the patient's requirements. So next is structured and unstructured data. As you can see in the picture, the structured data is mostly in the form of tables. It is organized, and unstructured data is not very organized. So structured data has rows and columns, and it adheres to a predefined model. It ensures consistency and helps in analyzing the data. So example, we'll go with a sales database. So a retail company maintains a structured database to track its sales. Like each sale record is organized into specific fields like name, address, or product name that the customer purchased, the quantity, the amount that is being sold, it is sold at, the payment method, etc. So when these kind of things are all recorded in a database, it will become easy for the developer to analyze which product is being sold at a very high cost, or which product was the most sold, etc. So now coming to unstructured data. Unstructured data does not follow a specific format for the data storage. It basically consists of audio, video files, image files, etc. So example can be take a social media platform like Twitter or Instagram or something. So the content shared on this platform is mostly in the form of text, hashtags, images, videos, emojis, etc. Right? So the content does not have a predefined format. People can express whatever they want. So you cannot give a format to what people can express. So it's unstructured data. Basically, what summary we can give is structured data is organized and has a specific format, and unstructured data lacks a predefined structure and involves various form of data like images, text, etc. So next coming to is GCP security. It has 5 parts: data encryption, identity and access management, IAM, that we'll be doing it in the next slides as well. Security key management, security compliance, and firewalls. So we'll start with an example to understand this better. So say we have a financial services company that is migrating its data and applications to Google Cloud Platform to leverage scalability and performance. So they need like high security measures to protect sensitive data from others, right? So the company uses Google's built-in encryption for data at rest, and this encryption that is there, it ensures that the customer data stored in Google is securely encrypted. So that is data encryption. The next is the company defines high like IAM roles and policies to control the access. So not many people can access the data. Only the people that have been defined their roles can only access the data. And firewall rules are so cloud Google Cloud's firewall rules are configured to restrict only to specific IP addresses or ports. So when those specific IP numbers or ports are given, only then they can access the data and rest cannot. And security key management utilizes Google Cloud Key Management Services, KMS, to manage the encryption key securely. So this ensures that only authorized users and services can access the encryption keys for data encryption and decryption. Next is security compliance. So when there's a the data is highly encrypted right now, and it belongs to the financial industry. So they are like very sensitive data, like the account number or something like that. And so GCP compiles with the financial industry standards like payment card industry, data security standard, etc., and integrates with them to audit the configurations for the compliance. So it makes sure that the data is secure enough. Next, coming to identity and access management, it also has 5 parts, namely roles and permissions, principles, resource hierarchy, fine-grained control, auditing, and monitoring. We'll go with an example for this as well. So, firstly, let's say there's an e-commerce website or company that uses GCP for its online shopping platform. So they need to manage the user's access to various parts of their cloud infrastructure, customer service, to developers and administrators. So the e-commerce company defines specific roles in the IAM, such as a customer support or a developer and an administrator. So these roles have different set of permissions. So the customer support has only read-only access to the customer order data, while the developer has access to modify the application code. So roles and permissions is that. So it will give a specific role, and they will only have that specific permission to do so. Principles is the company assigns IAM roles for different principles. So customer support team is assigned the customer support role, where they can only access the customer data, and developers are assigned developer roles where they are given access to the application code. Now, resource hierarchy. So the e-commerce company organizes its GCP resources in a hierarchical manner, where IAM policies are set at different levels, such as project level or folder level, to control the access. So the administrator role that is there is given at a project level to provide access to all the resources within that project only to that particular administrator. Next, coming to fine-grained control. So to maintain security and privacy, IAM policies are configured to grant access only to the necessary resources and actions. So customer support personnel can access order data but not access the application code. So auditing and monitoring is the company regularly reviews the IAM logs to track user activities and ensures compliance. So they can detect unusual access patterns and respond quickly to any potential security incidents. So basically, what IAM does it gives roles on who can access what data and what they can modify and how they can modify basically. So IAM roles, there are three major IAM roles, that is basic, predefined, and custom. The basic roles are fundamental IAM roles that are available by default on the cloud platform. And so they're straightforward and provide a simple way to assign permissions. So like only they can just have read-only access or something like that. The next one is the predefined roles. They are a set of IAM roles created and defined by the Google platform itself. So these roles are more specialized than the basic roles, where they are more valuable and have a little more access, and offer specialized permissions for specialized cloud services. And next, custom roles are user-defined IAM roles that organizations create to meet the specific access control requirements. So finally, the choice of the type of the IAM roles is decided by the organization's access control and the requirements that it needs and how to manage accounts. So Naveen can take over.
Okay. How do you interact with it? Basically, imagine you have a friend. How do you interact with them? There are like multiple means, right? Imagine he is on his phone. He's far away from your home. You can call him. You can use a video call. So the same way, us to interact with Google Cloud, we have four basic things. So I think you already would have started interacting with Google Cloud. Could you like name few of the means to interact with it? Anybody? Okay. So Google Cloud Shell, Google SDK, and Google Cloud Shell, REST-based API, and Cloud Console mobile app are the four important ways in which we interact with the cloud. So Google Cloud Console provides a web-based UI for you to manage Google Cloud projects and resources. It is a centralized console for all project data, execute common tasks using simple mouse clicks, access developer tools, cloud source repositories, cloud SDKs, and cloud cells are parts of it. And you can access product APIs using this GUI that's provided by Google. So let's see how we create a project. Every Google Cloud service you associate with is a project. And every project has three important attributes, which are project ID, project name, and project number. So you can look at the table. Let's go hands-on now and look at uh, how do you create a bucket? Just a second. So this is a basic dashboard where you can create your projects, and this is what the GUI of Google Cloud is. Here we can create a project. Just search. We can like create a new project, and then we don't have to give this. We can just give a browse. You can browse your location. So this is one way. You need to like add your billing account to do this, but yeah. So let's move on. So the next way of interaction is Google Cloud SDK. It's a command line interface for Google Cloud products. You would have probably used this. We generally use softwares like Vim, tools like Vim to access this. Browser-based CLI access to resources. No need to install a Cloud SDK privately with your system. You can use whichever is given in the GUI. It has 5 GB of persistent disk storage. So this is how we activate GUI. And you can you can basically communicate with it using this kind of compiler interpreter that's already inbuilt with the system. And so Google Platform is a combination of Google Console and Google Cloud Shell. So let's next see about REST-based API. So REST-based API is an API platform wherein you can communicate with the system using few controls and commands. So we can use multiple languages like Python, Curl, and tools like Hippie, Internet using principle of it is basically like it uses HTTP protocol to like do things. It is very simple, scalable, stateless, making them suitable for wide range of applications, including web service, mobile apps, and IoT. So imagine you want to code with Curl using Cloud Shell. You can use this codes, and Python, you can use this one. And this is the console that's provided for your Android or iOS phones, devices. And that's it from my side for today. This is this week's homework that we assign you every week. We have labs number 5, 6, 7, 1, 2, 3 to be done. So, thank you.